Hello everybody, and second video here today is going to talk about specific heat capacity. Now what specific heat capacity has to do with is how well or how poorly a material absorbs or reflects heat. For instance, when you wake up in the morning and you go in your bathroom and you step on the tile and it feels really cold, but yet you step on the carpet and it feels very warm, you're thinking that the carpet is warmer than the tile. In actuality, they're at the same temperature. What's actually happening is your body is at a higher temperature. So heat's flowing from you to those objects. It's just when you step on the tile, which is a very good conductor, heat's escaping very rapidly through your feet. When you step on the carpet, which is actually a good insulator and a poor conductor, it's escaping very slowly, so you don't feel it as much. So when you step on the tile, it's escaping very rapidly and it feels cold. That's because that tile is drawing heat very, very quickly out of your feet. That's why it feels colder. Now, specific heat capacity itself has a formula that goes with it, and that's Q equals mc delta T, where Q is your quantity of heat, and the quantity of heat we measure in calories. M is mass, and we're going to use grams, not kilograms here. C is your specific heat capacity. It's different for every material. The only one you should know off the top of your head is that of water. Water has a specific heat capacity of 1. Basically, they naturally started with that. We'll let water be the baseline, and everything else is based off of it. It is measured in calories over grams times degrees Celsius. And lastly, delta T is your change in temperature. That's in degrees Celsius. But keep in mind, that's always the final temperature minus the initial temperature. Now, I also don't want you to confuse Q, which is your quantity of heat, with temperature. Remember, temperature measures what direction heat's going to flow. Q is actually how much heat that is. Now, 2 examples here. One where we're adding heat and raising the temperature of material, and one where we're removing heat and therefore lowering the temperature of material. First example, how much heat must be added to 24 grams of aluminum, where aluminum, I'll give you that, its specific heat capacity is 0.215 calories per gram degree Celsius, to raise its temperature from 19 degrees Celsius to 21 degrees Celsius. In other words, we have this 24 gram sample of aluminum, and say if you happen to be in the electronics field, if you're working with conductors, superconductors, and so forth, they have to be at certain temperatures. Say you have to raise that 2 degrees Celsius. This is how we do it. First off, we're given a 24 gram mass. We know the specific heat capacity of aluminum is given, is 0.215, and it'll always be given unless it's what the quantity you're solving for. Water is the only one that you should know off the top of your head, and that's 1. Change in temperature. Final temperature of 21 degrees Celsius minus initial temperature 19 gives a 2 degrees Celsius change, an increase of 2 degrees. We're looking for Q. So we get Q equals mc delta T. Plug in 24 grams for M, 0.215 for your specific heat capacity, and 2 degrees Celsius for your temperature change. Multiply the numbers, you get 10.32 calories. In other words, if you add 10.32 calories of heat to 24 grams of aluminum, originally at 19 degrees Celsius, that same sample of aluminum would then raise to have a temperature of 21 degrees Celsius. So we added heat, which causes the temperature to rise. It's common sense. Next, we're going to do the opposite. How much heat must be removed from 15 grams of granite, which has a specific heat capacity of 0.19, to lower its temperature from 25 degrees Celsius to 21 degrees Celsius? So you're working with granite, and if it gets too high a temperature, its properties change. You have to keep it within a certain temperature range. Excuse me, a certain temperature range. So our mass is 15 grams. Our specific heat capacity, again, is 0.19 calories per gram degree Celsius. Change in temperature is final temperature of 21 degrees Celsius minus initial temperature of 25, giving a negative 4 degrees Celsius temperature change. We're looking for Q. Done. Same formula, mc delta T. The math is easy. Just multiplying numbers. 15 times 0.19 times your negative 4 gives a negative 11.4 calories. We know it's negative because we're removing heat. Over here, we have a positive example, so we're adding heat. So really, Q also is a vector in the sense it has direction. Either adding heat if it's positive or removing heat if it's negative. And you won't always have to solve for Q. Sometimes you may have to solve for mass or specific heat capacity or whatever, but it's still a basic formula, one that you should be able to use quite readily. But this gives you 2 examples where we're adding heat and we're subtracting heat.